Hi, today the easiest way to compromise your company is to get through your open source software supply chain. Hi, I'm Mihai from Chainguard, and today we'll talk about how to protect you from things like Mythos. We're helping you fix your vulnerabilities, and we're helping you get your software developers' experience to a much higher level. Good afternoon, just about. Thanks for joining this session today. As you can see, my name's Mihai, so it's probably not one of the easiest names to pronounce, but if you forget, always come over to a stand. I'm happy to talk about more than just my name. I know a couple of people in the room, and I'm from Chainguard, and today we'll be talking about secure by design and strong by default. Essentially, how can you build resilient software supply chains? Okay. We've already done this, it's a repetition. My background is in software engineering, cloud and Kubernetes, and container security, but also now I'm moving towards helping customers in terms of modernizing their applications, but in the most secure way, okay? You can talk to me about things like vulnerability management. I've done loads of vulnerability assessments, triaging, etc., from my software engineering days to my container security days. And if you want to connect, please feel free. There's also another QR code at the end, which helps you connect in a different way. So the Trojan horse about me is, one, I love black coffee. Funny enough, I'm wearing this jacket because on the train today, I actually spilled lots of coffee on myself. So while I was drinking that. Luckily, I've got brown trousers, so it kind of blends in. Look, this is the first time I've worn a white iron shirt in months, and I spilled coffee on myself. Look, anything. The second is I also love whiskey. But also, on the black coffee, I also love Afro House. So if you're a big fan of Afro House, I also love a DJ called Black Coffee, and he does amazing sets. You can watch his sets on YouTube. They are amazing. So if you don't want to talk about software security, you can talk about those very safe topics. So first of all, who's Chainguard? If this is the first time you're hearing about us and you haven't spoken to us, we're not talking about the chain guard on your childhood bike or your kid's bike. My kids have massive chain guards on their bikes, but unfortunately, it's not the one I work for. The important thing is, why do we exist? Because there is a reason why Chainguard as a company exists. Lots of teams here, CIOs have lots of mandates around things like modernizing their tech, allowing their engineering teams to move faster, but also at the same time, everyone has to do more with less. Everybody has to. I have to. You have to in your homes, but also at work, right? What happens is essentially, sorry, that did not, yeah, that's loading up. As teams are moving faster, they're using AI coding tools, so tools like Cursor, Claude Code, etc., to write their code so that they can move much faster than their competitors. The problem is, as engineers move towards this, there is a big hidden Trojan horse, and it's not about coffee or whiskey or anything. It's actually a much more serious problem. Now, the problem is, as you start to modernize, teams will start to think about more cloud-native technology, like containers, serverless functions, moving to the cloud, moving to on-prem, whatever it is, whatever they choose to do. So you get a crack team of engineers, those guys are net boats, they go on the internet, they grab a container, and they say, look, let's learn how to build on Python. They grab a Python container from the internet, and they plop it on a test sandbox, and they start to build on it. But as a CISO, as a CIO, they're not really hands-on with containers. These containers are built by someone on the internet. You're not really sure of all the executables. You could do some scanning. You can do some, bill of materials generation. Ultimately, what happens is teams will decide, okay, this is what we're going with. We'll build on Python because we have loads of Python engineers. It's easy to hire Python engineers. That's an example. It doesn't have to be Python. They scan this. They find some risks. It looks all right. The CISO up there in his ivory tower agrees with the security team and the engineers that will use this container. The problem is these modern applications that are built in the open source world have unnecessary executables. Now, these executables are the Trojan horse that is getting into your environment. What happens is as these then get brought into your organization, lots of what is in it is not understood. If you ask an engineer every single thing that's inside of this container, they don't know. They don't know if there is a crypto module in there that has insecure cryptography or cipher suits that are not allowed in your organization. They don't really understand all of that. Some might, most won't, right? But interestingly, only 20% of orgs agree that they understand everything that's inside of their workloads. The problem, number one, is the rise in supply chain attacks, right? So if you wanted to kill a leader, instead of trying to get into, for example, 10 Downing Street, you could just poison the lettuce where his sandwiches get made. So let's think about walking down London. Hot day, maybe this weekend, and you're thirsty. You see an unattended table with cups of water. They're sweating, they're cold. Would anyone drink from this? Would you grab a cup and drink this? Probably not, right? This is exactly what's happening on the internet today. When we need software, we go to the internet. We don't know who's built it. It might have a tag, a GitHub, alias. You don't know who it is, right? You grab that software and you start to use it. Even if you do know who built it, you don't know their practices. You don't really know the ins and outs of how it's built. But that's exactly what we're doing when you grab these components from the internet. This happened with Trivy. It's been attacked. It's happened with Light LLM. Shai Hulud, obviously, had its 4th or 5th coming this week with 600 libraries exploited, but also Axios. This is the biggest one that's happened recently. So if you build on anything JavaScript, you probably most likely have this, right? Axios has 300 million downloads a month, and it was just compromised. This is one of the big risks, right? So because the attackers have realized they can't hit what you have deployed in your Red Hat servers, etc., just compromise the software. Also, they're now thinking of compromising your libraries like Axios, where they'll go, you know what, let's target the way this gets distributed, right? Instead of targeting the kitchen where it gets cooked, let's look at the pigs where the sausages get made. And there is almost 98% of the malware is inserted at the point of build or distribution. Now, the engineers who build these open source software, they're not security experts usually. What will happen is they will have amazing code, but very lax build practices, okay? Attackers take advantage of this, insert the supply chain attacks, and then you pull it. Now, what happens is we automatically assume trust. Oh, everybody pulls from NPM. We have no choice. Really, we almost have no choice. Or we are building on Python. We have to pull from PyPI index. We assume that PyPI is doing amazing work in terms of security, okay? However, the visibility on what is pushed in there does not translate to a trusted software artifact, a trusted source. For example, I can attack a maintainer's email and push an artifact which is not linked to the repo that he has published as the source. So i.e. you're saying, this comes from X farm, but actually I've inserted something that comes from outside of the country, like the horse meat scandal. So we just default insecure software, right? You're pulling unsigned images, you are using software that has unknown provenance and has very inconsistent patching techniques. I'm just thinking of that as someone who's in charge of security, and every day it keeps lots of leaders up with things like Mythos coming. You're probably thinking about, okay, we have all these software components, they have all these risks. Yes, we're scanning, yes, we're finding these issues, but do we know exactly what's in there? Do we know the risks? And how can we start to tackle this? Keeps loads of people up at night, including us, right? And we're thinking of how to solve this for you, but you're thinking of it from a different angle. So, second table. Would anyone drink from this? Probably not. You could choose the ones on the left, which are cleaner, but really you don't know what's in there. It could be poisoned, could have laxatives in there. It could be as filthy as the ones on the right.
Transparent, but whether it's transparent there or not,
That is it. So you can see what is being pushed on the internet, but do you know exactly what's in it? And that's the main problem. Second problem is innovation versus remediation. As you think about modernizing your application stacks, that person looks a bit familiar, but this is what we do when we build and modernize our applications. We just go, look, we need to move fast. We'll do it how everyone else does it, pick the clear cup, but we don't really know. Now, as you build the software and ship it, there's lots of points where there'll be failure points, right? And you start to think of how you put in stops at every single point. The problem is, as you start to put in all these stops and checks and security standards, you start to introduce loads and loads of friction. So if you think of, you have to do risk assessments, threat modeling, you have to scan, you have to triage the CVEs. You're doing this with the same engineering team, and they will be worn out. Because these software engineers have come into your org, what they want to do is actually build products, but you've got them stuck doing things like remediation, image patching, verification, and SBOM creation, but also building updates. Now, this is not what they want to do. This is not what they get judged on as engineers. And I always say to the engineers when I meet them at dev events, nobody gets a promotion for doing any of these, right? This is grunt work that nobody enjoys. It doesn't benefit anyone. It actually prevents you from actually innovating as you should. Really, what they want to do is build new features. What we're all here to do as companies is build new features, get ahead of our competition, sell new products, keep the company alive. If we're stuck doing grunt work, that doesn't happen, okay? Now, as we think about things like CVEs, and CVEs is one part of it. It's not the main, it's not all of it, but it's one part of it. If you think of the CVEs, which everyone likes to focus on, as you start to build, I'm not going to go through all of those. It's a bit of an eye chart, but I think there'll be a way to get this across to you. But otherwise, you can always reach out to me, and I'll send this to you. As you go through the software development lifecycle and building out your supply chain, your software supply chains, you start to think of how you can make it more resilient, how you can make it safer. Are we covering all the bases? The problem is all of these things start to add friction. They reduce the developer experience, and they take away from the experience of developers. One, leaves them demotivated. Also, two, it stops you from building what you're meant to be building, right? All of this friction actually makes your organizations less efficient and also more prone to attacks, employee attrition, etc. Okay? That starts to increase at every single point. What we're trying to do is to build a single trusted source for all of your open source. And that's what Chainguard does, in a nutshell. Now, who would drink from any of these sources of water? You're walking somewhere, maybe the Excel, you see that water fountain, you fill your bottle up, right? Or you go walk into a Tesco, you see bottles of Volvic, you'd buy there, right? Because they are trusted sources. Volvic is a well-known brand, so is Evian. So you know that they are doing what's best because that is their USP. It's water. That is what Chainguard wants to do, right? That is what Chainguard is doing, and that's why we want you to think about building a resilient software supply chain by thinking of a trusted source for all of your open source. Instead of going to the open internet and downloading PyPI packages, you come to Chainguard. We have exactly the same artifacts. You pull them from us, and you build your applications in a secure way with provenance. It's attestable in case of an audit, and we hold ourselves to a very stringent SLA for fixes, and we rebuild our artifacts every single day, okay? Now, we cover over 2,400 of the most popular projects in terms of containers, but we also have, that number is probably a bit old in terms of 100,000 libraries. Actually, we're probably over 300,000 libraries at the moment. covering Java, JavaScript, and Python, but we are moving to all other ecosystems. And the idea is you grab your open source containers. As you build on them, you build with secure libraries on top. So every single thing has a source, a provenance, it's signed, and you know exactly what's in it. That's important. As your engineers vibe code. Everything we build is reproducible, so you can see exactly what's in it. You can do it yourself. You can verify from open endpoints, things like Sigstore. All the components we built are built from source. So we maintain hundreds of thousands of components of what we put into the software, and it's fully transparent for everyone, okay? Fully tested, and what we're helping teams do is, one, achieve compliance, maintain the compliance. If you're trying to hit things like Cyber Essentials, or if your company is going for things like FedRAMP or CMMC certification, we help loads of companies actually achieve that, and you can see some of the use cases on our website. Okay? We reduce the cost of engineering toil so that those devs are not crying anymore when they're just having to do triaging and patching. We're building a secure source for open source software. This is something that is it's a principle where it needs to be thought about today, as it is. And we're helping you accelerate and build better products so that your teams are happier, they're building better products, they're building them in a secure way, and the vibe coding is actually done properly, not just by dumping loads of excess slop. Now we plug into your existing tool chain, so you don't need to change a lot. Actually, our changes are so minimal that a lot of times when I test with customers, it's done in a few hours, and it's a one-time change, okay? An example of one of our containers. This is an example. That chart you see there is actually the number of CVEs on the left-hand side, sorry, on the right-hand side, is the CVEs in the open source Node.js container. Most people build on JavaScript. If you have a front end, you're probably building on JavaScript. That chart tells you the number of CVEs on the open source Node.js container. On the left-hand side is actually the Chainguard chat, and you can see there's nothing, basically nothing there, right? Now, even if something does come up, we commit to an SLA of 7 days for any critical CVE and 14 days for everything else. We achieve way lower than that. I think criticals we're patching in under a day at the moment, but we also have a very stringent SLA for any CVEs that have an exploit, which is 24 hours. We will patch it, and you can pull the new version and continue building your amazing products. But don't just take my word for it. You can see that chap there. I don't know if you can read it, but he essentially said he got to go on a date with his wife because he didn't have any CVEs to patch. We have peers like your peers, like the CISO at Trustpilot, who essentially says they have trust in the name of their company, but Chainguard helps them live up to that. Okay. Our engineering and security teams, our customers love us, but this is a message that came to one of my colleagues from one of our customers, and they had just signed, and he said, look, using these containers feels like cheating. You essentially just switch, and the problems are gone. I have customers who have got rid of 300,000 vulnerabilities. One, storing those tickets are a nightmare, but two, they don't have to triage them, they just carry on building, right? Small teams are able to move fast, and that's what we're trying to do, to be the trusted source for all of your open source, so that when you build, your software supply chain is resilient and it's secure, allowing you to move faster in the best way. Thank you. So you can scan that and get in touch with us as well. My name's Ihang again, and thank you for taking the time.